facial nerve. You see, if you want to understand the function of the facial nerve, you can understand it by this acronym, FEAST. That is FE for facial expression, A for the anterior two-third of the tongue, because it carries sensation from the anterior two-third of the tongue. And then the S, it carries sensory information from the external ear. And then T for the taste sensation it carries from the anterior two-third of the tongue. So this is virtually the summary of the major functions of the facial nerve. So now the facial nerve has a very complex journey. So if you can remember when I was discussing the pons, I made mention that the facial nucleus, is also found within the pons. And if you can remember, I also made mention that it is one of those nerves that comes out of the pontomedullary junction. So if you can remember, this nerve, the nucleus itself, lies anterior to the abducens nucleus within the pons. And so it is on fibers as it lies anterior to the abducens nerve, which is this nucleus. So this is abducens nucleus. So this nucleus of the facial nerve is the facial nucleus proper. So this axons from this nucleus, they loop round the nucleus of the abducens before the axons finally come out of the pontomedullary junction. Are you clear? Apart from this facial nerve, motor nucleus of the facial nerve, we also have other nuclei associated with this facial nerve. We have about 3 more nuclei. These 3 more nuclei, first and foremost, it includes this superior salivatory nucleus, which I also discussed while I was discussing the pons. So the superior salivatory nucleus is also associated with the facial nerve. Similarly, there is also one nucleus, what we call nucleus of tractus solitarius. This nucleus located from the medulla oblongata up into lower portion of the pons. So also we also have another nucleus of the trigeminal nerve, what we call spinal nucleus of the trigeminal nerve, that will also contribute to the formation of the facial nerve. So we have 4 nuclei contributing to the formation of the facial nerve. The first one we said, the motor nucleus of the facial nerve, which we call proper nucleus of the facial nerve. And then we also have the superior salivatory nucleus, the second nucleus. The third one is the nucleus of the tractus solitarius, and the fourth one is the spinal nucleus of the trigeminal nerve. These are the 4 nuclei that contribute to the formation of the facial nerve. So let us take each of these nucleus and see its journey, the course of each of these axons from each of these nucleus. And then we now see how they combine together. If you now remove the axons coming from the facial nerve motor nucleus, the proper facial nerve nucleus, which is this one in red, the remaining 3 axons coming from the 3 nuclei, that is fibers coming from the superior salivatory nucleus, fibers coming from the spinal nucleus of the trigeminal nerve, and also fibers coming from the nucleus of the tractus solitarius, as they come out of the pontomedullary junction. These 3 bundles of axons like this is what is called nervus intermedius. Some of you may come across it within some of your anatomy textbooks. And this nervus intermedius, some of the authors of the anatomy books regard this as the 13th cranial nerve. But it's not true, because this is not a separate nerve per se, because it is part of the facial nerve. If it were to be a separate nerve, then it can be called a cranial nerve. But rather, this one is just a portion of the facial nerve. That is why it can never be considered as the 13th cranial nerve. So, this nervus intermedius, together with the motor component of the facial nerve, they bundle together, and then they enter into the internal auditory meatus that is facing the posterior cranial fossa. But before then, the portion of the facial nerve from the frontomedullary junction down to the internal acoustic meatus or internal auditory meatus, this length is almost 15 millimeter length, or approximately 1.5 centimeters. So that means it has a shorter segment within the cranium. Are you all right? So it has about 1.5 centimeters within the posterior cranial fossa before the whole facial nerve enters into the internal acoustic meatus. So from the internal acoustic meatus, this nerve enters into what we call facial canal. Okay? So the facial canal, it has three components. That's what we call labyrinthine part. This is what we call labyrinthine portion. This labyrinthine portion is directly above the vestibule of the inner ear. Then we also have what we call the tympanic portion of the facial canal. This is the tympanic part or the horizontal part of the facial canal. So this labyrinthine portion can be considered as the oblique portion of the facial canal. That is the labyrinthine, because it is like obliquely like that. So it's either you call it labyrinthine portion or oblique portion of the facial canal. Then followed by the tympanic portion of the facial canal or the horizontal portion of the facial canal. And then finally, you have the vertical portion of the facial canal or the mastoid portion of the facial canal. So this is the mastoid portion of the facial canal. So this one is either call it vertical part of the canal or mastoid portion. This one you call it horizontal or tympanic part of the facial canal. And this labyrinthine, you call it labyrinthine portion or oblique portion of the facial canal. So now let me just take the motor component of the facial nerve. So as this nerve comes out of this frontomedullary junction, this nerve enters together with other components, enters into this facial canal, the labyrinthine portion. As it comes towards the middle ear, this tube-like structure here that I've drawn is the middle ear cavity for easy understanding. Although actually it's not exactly the way I draw it. It's not like a cube per se, but for easy understanding, I drew it like to be a Maggie cube, so to say, because it has four walls. It has anterior wall, posterior wall, medial wall, lateral wall, roof, and floor. So the middle ear has all this. Are you clear? So as soon as this labyrinthine portion of the facial canal comes into this junction of the roof and the anterior wall, this canal enters into the middle ear cavity to join its own horizontal portion. So this facial nerve, as it comes through this labyrinthine portion of the facial canal, it makes a bend to conform with the bending of this labyrinthine portion of the canal. So by the time it comes towards this bending, it meets one small ganglion. This ganglion is called the genu of the facial nerve. This is facial nerve, ganglion, facial nerve ganglion. So this motor component, as it comes, it makes a bend to enter into the facial nerve ganglion. So it now forms a bend, and that bend is called the external genu of the facial nerve. The internal genu of the facial nerve, that is this bend. As it comes from the motor nucleus, it forms a bend behind the abducens nucleus. So this bending, the looping that it forms around the backside of the abducens nerve to form this facial colloculus within the fourth ventricle, that looping is what we call internal genu of the facial nerve. And so this one is the external genu of the facial nerve. So it has two bends. So as soon as it comes into the facial nerve ganglion, this motor component enters into the ganglion without synapsin. So there's no synapsin of this motor neuron. So it comes out of the ganglion, enters within the medial wall of the middle ear cavity through this horizontal portion or the tympanic portion of the canal, and until it now reaches the posterior wall of the middle ear, where it enters, where it continues within the canal here, which is the vertical part of the canal. So this is what we call the mastoid portion of the canal. So this motor fibers, as they come through the vertical portion of the canal, so it comes out of the canal. You get it? But before it comes out of the canal, it gives a branch to one small, tiny muscle. This muscle, within the posterior wall of this middle ear cavity, there is what we call stapes bone. And this stapes bone is, associated with one small muscle, what we call stapedius. This stapedius muscle is responsible for dampening any excess noise coming from the external environment. Because at times when you are just hearing to music or you are hearing to any voice or whatever, the voice, the auditory stimulus there, it reaches the tympanic membrane. Vibration is set up and it goes through these three ossicles, malleus, uncus, and stapes. And with relation or with regard to this stapes, there is that stapedius muscle, which is a tiny muscle. So this nerve, the motor nerve, supplies these muscles. So in case that this nerve is being tampered, cut up in this vertical portion, before it supplies this nerve, that means around this side, this muscle is no longer going to be supplied by that nerve. And so the nerve, the muscle is going to be paralyzed. And so the muscle will now, the dampening of this excess noise from the, from the ear is not going to happen. And so that's what is going to be called hyperacusis. You get my point? The condition is known as hyperacusis. So this hyperacusis is like, too much of hyperacusis. So the noise is going to be exaggerated, because the muscle that is supposed to be dampening that noise is no longer, functioning. So after it comes down, it comes out of this vertical portion of the canal through one small foramen known as stylomastoid foramen. The styloid process is a small finger-like projection lying anterior to this stylomastoid foramen at the base of the skull. So this is a styloid process, finger-like picked, pointed projection lying anterior to this foramen and also anterior to the mastoid foramen lying behind your ear like that. So you have a mastoid process. If you touch just inferior to your lower part of the ear, you are going to feel the mastoid process there. So just anterior to it, that is why you can find the styloid process. In between the two, that is what you have. You have that where you have that foramen. So it is called stylomastoid foramen. So the facial nerve comes out of that foramen. As soon as that nerve comes out of the foramen, between these two structures, it gives its first branch, what we call posterior auricular branch. This posterior auricular branch, it gets out behind the back of the ear, external ear, and so as it comes behind the external ear, it gives a branch to what we call posterior auricular muscle here at the back of the ear. You see, some people can try to move their own ear either upward, downward, and backward. Are you clear? Especially animals. But humans actually, they find it difficult to move this, ear like that, this external ear. But then actually there are muscles. We have superior part, we have posterior part, and what have you. So the posterior auricular muscle is being supplied by this posterior auricular branch of this, branch, And so the remaining nerve continues backward to supply the occipital part of the occipitofrontalis muscle, or fronto-occipitalis, or occipitofrontalis muscle. That muscle is responsible for our, frowning of the face. So the occipital part of this occipitofrontalis is being supplied by this posterior auricular branch. Are you clear? Apart from supplying the posterior auricular muscle at the back of the ear. So the nerve continues down again to give two more motor branches. These two more motor branches, one of the branch supplies stylohyoid muscle. One muscle that links the styloid process with hyoid bone here. There is a hyoid bone here, just below the chin, and so this muscle comes down like that, from the hyoid process, from the styloid process down to the hyoid. So this now, this branch goes to this muscle like that. So we have stylohyoid branch supplying the stylohyoid muscle, and then we also have another branch supplying the posterior belly of digastric. So we have digastric muscles. One line posterior, one line anterior. You get it? They form something like an angle here, at the base of the chin like that. So this posterior belly of the digastric, this nerve, it goes to supply this posterior belly of digastric. So these two branches, they emanate immediately after that posterior auricular branch. Are you clear? So the main nerve, after giving these three branches, it now goes forward to enter into the parotid gland. So by the time it enters into the parotid gland, it divides the parotid gland into two segments. You get it? Deep branch, that is deep to the nerve, and then superficial branch, that is lying superficial to the nerve. So the nerve is sandwiched. If this is the nerve here, so the nerve is between the two parts of the parotid gland. So you have one portion that is deeper here, and then you have another portion that is superficial to the nerve. So within the parotid gland, this nerve divides into 5 branches. Are you clear? So these 5 branches, for you to be able to understand or to remember the supply of these branches, I said test Zoho before making comment. Are you clear? So test, it gives a temporal branch. So Z, zygomatic branch. Before, vocal branch. Are you clear? Then making marginal mandibular branch. And then comment C for cervical branch. Are you clear? So the reason why this one is called marginal mandibular branch is qualified because if you can remember trigeminal nerve, we said it has 3 components: ophthalmic, maxillary, and mandibular. So for you to qualify that, that is why this one is called marginal mandibular branch of the facial nerve. So if you can test Zoho before comment, you can easily understand the branches of this facial nerve. Are you clear? So now let us see where this branch is supplied. The temporal branch, as it goes from the lateral side of the face, it comes forward. But before it comes forward, it also gives branches, to the lateral fibers of the frontalis muscle. We have frontalis muscle here. If you can remember, I said we have occipitalis. So we have a tendon uniting the two together. Occipito, frontalis, and so the occipitalis portion is supplied by that posterior auricular branch. The frontalis part is being supplied by the temporal branch, and after supplying the frontalis muscle, it also supplies the orbicularis oculi muscle. Are you clear? So these are the two major muscles supplied by this temporal branch, frontalis and ocularis oculi muscle. Ocularis oculi muscle surrounds the eye. You understand? This is responsible for closing eye. If you want to close your eye very well, that orbicularis oculi muscle is responsible for closing your eyes tightly. And so that temporal branch, of the facial nerve supplies that orbicularis oculi muscle. The zygomatic branch, as it comes forward, it supplies zygomatic muscles, both major and minor. So we have zygomatic muscles coming from the angle of the eye down to the angle of the mouth. Are you clear? And the nose. So we have zygomaticus minor and major together. And so this zygomatic branch supplies branches to these two muscles. Are you clear? So it also gives a branch again to the orbicularis oculi muscle. So that means this orbicularis oculi has how many supplies? Two supplies. Are you clear? What I also forgot to tell you, this temporal branch also supplies one small muscle that is lying in between, the two eyebrows. That is the procerus. So the frontalis, the temporalis, the temporal branch supplies that procerus muscle. So now we've seen that the zygomatic branch supplies the zygomatic major and minor. And also, it also supplies, some tweaks to some of the muscles, around the oral cavity. The buccal branch, as it comes here, there is one muscle here, what is known as buccinator, muscle that we use to trumpet. You understand? So this buccinator, the buccal branch, supplies a branch to it before it finally goes to supply the muscles around the oral cavity, the mouth. That is what we call orbicularis oris. This orbicularis oris is being supplied by this buccal branch. Apart from supplying the buccinator, the buccal branch supplies the orbicularis oris. Then the marginal mandibular branch. The marginal mandibular branch supplies the muscles that are lying, around the chin. There's one muscle that depresses the lower lip, the depresso anguli oris. This depresso anguli oris depresses this down. Are you clear? So this depresso anguli oris, it is supplied by the marginal mandibular division of the facial nerve. There is also this the depresso labii. This is the depresso anguli oris at the angle of the mouth. That depresso anguli oris, it depresses the angle of the mouth. And since the second muscle that depresses the lower lip is the depresso labii inferioris. So this depresso labii inferioris is also being supplied by this marginal mandibular branch. So now we have seen that the marginal mandibular supplies the depresso anguli oris and also supplies the depresso labii inferioris. Are you clear? Similarly, there is one small muscle lying in the midline. That is what we call mentalis muscle. So mentalis is also being supplied by this marginal mandibular division. So the cervical branch of the facial nerve it comes down to supply one large muscle that comes from the, lower part of the neck like that, some upper part of the shoulder. That's what we call platysma. So platysma muscle is being supplied by this cervical division of the facial nerve. So we have seen how many divisions? 8 division. 5 as they come out of the parotid gland, and then we have 3 before it enters into the parotid. Posterior auricular, nerve stylohyoid, nerve 2, posterior belly up, digastric. And then you have this your 5 branches, making 8 branches as it exits out of the stylomastoid. That is the motor aspect of the facial nerve. So now, let me take the other fibers of the facial nerve. That is fibers that synapse with the nucleus of the superior salivatory nucleus. So fibers that come to the superior salivatory nucleus, they originate, the superior salivatory nucleus, they are called, the axons get out of this superior salivatory nucleus. As soon as they exit from this superior salivatory nucleus, these are what we call preganglionic parasympathetic fibers, because they supply the submandibular and sublingual glands as secretomotor fibers. So they now, stimulate the secretion of saliva from these 2 glands. So the preganglionic parasympathetic fibers from the superior salivatory nucleus, so they exit also at the same pontomedullary junction, follow the motor component of the facial nerve, enter into the internal acoustic meatus, enter into the facial canal, and then from the facial canal, from the labyrinthine part, the axons enter into the facial ganglion. As this enter into the facial ganglion, they enter without any synapse, because this facial ganglion actually is not a parasympathetic ganglion. So it enters inside it without making any synapse. The nerve comes out of it, follows this tympanic portion of the facial canal, and then descends along with the motor part through the vertical portion of the facial canal. As soon as it comes into the vertical part of the facial canal, these parasympathetic fibers, they exit out of the middle ear. There is one small fissure here, what is called pterygotympanic fissure. It is a small, crack, just like a crack, just like a fracture. If you check the base of the skull, you will see it just like a crack lying at the anterior wall of the middle ear cavity. So this preganglionic parasympathetic portion of the facial nerve, as it comes out of this vertical portion of the canal, it continues within the middle ear cavity, and then it exits out as through this pterygotympanic fissure, and then it joins the lingual nerve. If you can remember, we said that the trigeminal nerve has 3 branches: ophthalmic division, maxillary division, and mandibular division. As soon as the mandibular division of the trigeminal nerve comes out of the foramen ovale or foramen ovale, we have branches coming from the mandibular division. One of it is the lingual nerve. That lingual nerve, it, carries sensory information from, the anterior to third of the tongue. Are you clear? The sensory information, pain, touch, pain, temperature, touch, and pressure like that. So this preganglionic parasympathetic portion of this nerve, as it comes, it joins the lingual nerve as what we call coda tympani. So it joins the lingual nerve, but it continues until it reaches underneath the tongue. As soon as it reaches underneath the tongue, it didn't go together with the lingual nerve anymore. So it now slips out of the lingual nerve, and then it synapses with the submandibular, gland. So that submandibular gland, as it enters postganglionic parasympathetic fibers, they come out from that submandibular gland to supply the submandibular salivary gland, and also some of the fibers will go to the sublingual gland, so that they act as a secretomotor fibers to these two glands, so that they stimulate the secretion of saliva from these two glands. Are you clear? Apart from supplying these two glands, these postganglionic parasympathetic fibers, they also supply small glands that are found, salivary glands that are found in the floor of the mouth, and also by the side of the cheeks from the inside. Are you clear? So now we're saying these fibers coming from the superior salivary nucleus. So what I will also emphasize, these fibers coming from the superior salivary nucleus, they are not only supplying salivary glands, they also supply lacrimal gland. What it means is that once these preganglionic parasympathetic fibers enter into the labyrinthine portion of the facial canal, this, I made it in green. So the portion that will go to supply the lacrimal gland exits out of this, canal. You get it? So it enters into what we call facial hiatus at the base of the skull. Are you clear? So at the base of the skull, it enters into that small opening, and then it enters into one canal. Although it is not actually a complete canal. When you now open, when you cut across the cranium, you remove the calvaria. So you are going to see at the floor of the middle cranial fossa, you will see that there is a small groove, what we call greater petrosal groove, and slightly covered by a thin plate of bone to form this greater petrosal canal, through which this nerve, as it enters here, is now called greater petrosal nerve. Are you clear? So this portion of the fibers of the facial nerve emanating from the superior salivary nucleus, and they pass through the facial hiatus, they enter into greater petrosal canal to become the greater petrosal nerve. So this greater petrosal nerve, it enters into the foramen lacerum. That foramen lacerum actually is not some of them call it lacerum canal or foramen. It's not even a foramen per se, but rather it is just blocked by a cartilage in life. But after maceration, in your cadavers, when you finish dissection, we macerate, we clean the head and whatever with some chemicals. So the cartilage now gets dislodged, and so you see the opening. That is why it is called a foramen, but in the real sense, life is not a foramen per se, it is covered by a cartilage. But then, this greater petrosal nerve comes out of this foramen, but before it comes out of the foramen, there is internal carotid artery, which is this one. Internal carotid artery, it enters into the cranium through this, through the carotid canal via this foramen lacerum. So there are some sympathetic fibers from the internal carotid artery. These sympathetic fibers from the internal carotid artery, they give a slender sympathetic nerve that joins the greater petrosal nerve. These two nerves together, they are called Vidian nerve. You get it? So this Vidian nerve is a combination of greater petrosal nerve plus the sympathetic fibers coming from the internal carotid artery. So this Vidian nerve enters into the pterygopalatine fossa. If you can remember, I think yesterday I discussed about this ganglion line in the pterygopalatine fossa with regard to the fifth cranial nerve. So this pterygopalatine fossa contains pterygopalatine ganglion. So this is pterygopalatine ganglion, which is parasympathetic. So this preganglionic parasympathetic fibers, together with these sympathetic fibers here, the parasympathetic component, synapse with the neurons within this ganglion. The postganglionic parasympathetic fibers, they now go to supply the lacrimal gland. Are you clear? But along its pathway, this portion of the these parasympathetic fibers from the facial nerve meets with the lacrimal nerve coming from the ophthalmic division of the trigeminal nerve. If you can remember yesterday, we said that the ophthalmic division now gives rise to 3 branches: frontal, nasociliary, and lacrimal. So the lacrimal portion supplies the lacrimal gland. So that lacrimal component of the ophthalmic nerve, it joins with this lacrimal component. So they now go together. Similarly, if you can remember the maxillary portion of the trigeminal nerve, as it enters into the foramen rotundum, it gives rise to the zygomatic branch. Are you clear? So that zygomatic branch also, it goes along with this. You get it? So that one also follows, this part to also supply the lacrimal gland. So the lacrimal gland is being supplied by multiple nerves, from the facial nerve, from the lacrimal nerve, from also portion of the zygomatic division of the maxillary nerve. Are you clear? So now I think we are done with this nucleus. So the other one of importance is these sensory fibers. Sensory sensation from the lower part of the ear, this lobule, you get this lobule here, and there is a concha inside the external ear here. So sensation, as I'm touching now, this touching I'm feeling it is as a result of these nerve fibers around the concha and the lower aspect of the external ear. So this sensation of pain, temperature, pressure, crude touch, and what have you, so they pass through these fibers, these axons, as it enters through this stylomastoid foramen to follow the motor part of the facial nerve. So this one in black accompanies it, ascends up through the vertical portion of the facial canal, then goes through the horizontal part, then through the oblique part, and then it now gets out of the internal acoustic meatus, and then finally enters through the frontomedullary junction until it finally reaches the spinal nucleus of the trigeminal nerve, where it makes a synapse. And then from there, it's taken up. You get my point, to the thalamus. Are you clear? So this is the only component for the sensation from the external ear at the level of the concha and lower part of the external ear. So that portion of the sensation, the axons, they pass through the stylomastoid foramen, and then they go around until they reach the spinal nucleus of the trigeminal nerve. The last one, but not the least, is the nucleus of the tractus solitarius for taste. So taste sensation from the anterior to third of the tongue is being carried by these, taste fibers. So these taste fibers, the axons, they now pass out of the tongue and then follow the lingual nerve and also the tympanic nerve. So as tympani, so as it comes and joins the lingual nerve and it joins the lingual nerve, so as it reaches the coda tympani, it gets out of the lingual nerve, and so now it joins the coda tympani. So that it means that coda tympani, initially it is formed by lingual nerve plus the fibers coming from the spherosalivatory nucleus. Then later on, the coda tympani is formed by the fibers carrying taste sensation and the fibers from the spherosalivatory nucleus. Are you clear? But below here, all the 3 fibers form the coda tympani. Lingual nerve, fibers carrying taste sensation, and also fibers for the secretomotor activity of submandibular and sublingual salivary glands. So now, these fibers that they carry taste sensation, they pass all along until there is the pterygotympanic fissure, and then the fibers enter into the middle ear cavity until they now reach, the vertical portion of the facial canal, and then they ascend up. This is the horizontal part of the canal, enter the genu of, the facial ganglion without synapsin, and then it gets out of the ganglion until it now gets out of the oblique portion of the canal, gets out of the internal acoustic meatus, and then enters, the pons at the point where medullary junction, and then it now synapses in the nucleus subtractus solitarius before it finally gets out of it. The second order neuron gets out until it now reaches the thalamus. Are you clear? So these are all the components of the fibers of the facial nerve. So let us have a break, and then we answer some questions before we finally go into the definition of the facial nerve.